All right, now we're back into section 2, which our learning goal for this one is still under the same central question, but our learning goal is going to be students will be able to identify the period and group of any element on the periodic table. Now, we're going to have a couple of different things that we'll utilize in order to do this, but again, you want to follow along in your notes. The information you need to write down is going to be underlined and bolded, so make sure that you're paying attention. Now, don't only look out for those things that are underlined and bolded. If you need to make little side notes or any other information that you think is important for you to remember, please do not hesitate to write it down, along with any questions of things that are still not making sense. So, let's move on. Now, the first group that we're going to look at is called the alkali metals. These are going to be the metals that are found in group 1A, or all the way to the left of your periodic table. Notice that it doesn't include hydrogen. Hydrogen's a non-metal, so we won't include that in there. Now, the atoms of the alkali metal have a single electron in their outermost level, or in other words, they have one valence electron. This is going to be what we look at when we talk about, again, bonding and how they are going to bond. This will determine their reactivity. Now, in terms of characteristics, they're shiny, they have consistency of clay, and they're easy to cut with a knife. These are going to be your very, very soft metals, but also, again, very, very reactive metals. So we want to pay very close attention to that. Now, these are the most reactive metals that we have on the entire periodic table. Now, they react very violently with water, and they're never actually found free in nature. So I wouldn't just walk as I'm digging through the soil and come across a big chunk of sodium. Why? Because it will start to react with things in the air. And if there's any moisture in the air, as you can see from the picture, we get a nice explosion that happens along with it. Now, what about our second group? Our second group is called the alkaline earth metals. These are going to be the group 2A or elements. So now we're moving over to group 2A, or the second group over from the left. Now, these also are never found uncombined in nature. They're not as reactive as the group 1A metals, but they are pretty reactive. Now, these elements have two valence electrons. So again, pointing to the idea of how we're going to utilize this information in terms of bonding. Because they only have two valence electrons, a little bit later on we're going to see how those properties sort of play out. Now, these are going to be the elements that include things like magnesium, calcium, any of those elements in that group 2, barium, strontium, and so forth. Our third group that we're going to talk about is called our transition metals. Now, when we think the word transition, the thing I want you to think of is think of the word change. Why do I want you to think of the word change? Because when we start talking about how it works in bonding, these are the ones where their charge will actually change on us. Now, these, as you see, make up the largest group of our periodic table. That big group or big chunk sitting right there in the middle. Now, these metals are the most familiar because these are the ones we come in contact with on a regular basis. This is your copper, your tin, zinc, and so forth. They are all very, very good conductors of heat and electricity. Now, because of their different properties and different colors and textures and how they arrange and what they bond with, these are going to be used often to color paint. So those who are artistic, many times you may be using say a tempera paint or an oil-based paint or different things like that. And how they were able to get those colors is by mixing in different amounts and types of metals that will actually give off those colors when they react. Now, transition metals usually have one or two valence electrons, but they have a little ability to do something that the other ones can't. They can lose electrons from the lower levels, but again, we'll talk about that a little bit later. These elements have similar properties to one another and other metals, but the properties don't fit within any other family. So these are sort of the oddballs of the periodic table. They have some similarities, but they're very, very different. Now, our next group, and I do realize that we skipped over some, and it's because we don't really talk about the properties of those groups. The next one that we're going to talk about are called the halogens. Now, the halogens are group 7A metals. The elements in the family, fluorine, chlorine, bromine, iodine, acetine. Now, these have 7 valence electrons, which explains why they're the most active nonmetals. So the alkali metals, we said, are the most active metals, and these are the most active nonmetals. Now, they're never found free in nature because of the fact that each of the atoms only needs to gain one electron to fill their outermost energy level. they react with metals and they form salts, or alkali metals, sorry, and form what we call salts. So when we talk about salt, don't think it's just sodium chloride like we always use at home. It could also be potassium chloride or many of these different compounds, which we'll talk about later in the year. Now, keep in mind that, again, fluorine is the most reactive of them all. It's the one that's closest, and what we're going to talk about in the next video is how we have our electronegativity, and this is basically on the ability to attract electrons from another element. Again, we'll get there in a second, but you want to keep your eye on fluorine because we're going to use it a lot and talk about the properties of it a lot. Now, our next group is called the noble gases. Now, these elements are found in group 8A, all the way to the right end of our periodic table now. So we've gone from the left and we moved all the way across to the right. Now, these are going to be gases that are very, very unreactive. They can react. Certain ones will react in certain situations, but for the most part, they will not react. Now, the reason why they're inactive or that they don't react with other elements often is because their outermost energy level is full. In the other ones, we talked about how they 1 or 2 or however many valence electrons. This one has a full 8. And because of this, we call them inert. We say that they're not going to form any compound, or they're basically unreactive. Now, the noble gas family includes helium, neon, argon, krypton, xenon, radon. These are just the basics of what we'll talk about throughout the year. Our last and final group is the intertransition metals, and this is that group that's there at the bottom. Now, in a normal periodic table, these are in the original, periodic table, these would actually fit right in here. Oops. Fit right in there. Now, there's a man named Glenn Seaborgium. He actually has Seaborg, sorry. He actually has an element named after him now. He was the one who came up with the idea, because the properties of this group was so diverse and many times they were man-made, that we should bring those out of the main periodic table, which would shorten it and allow it to fit a little bit neater on a page, but it would allow us to then talk about or discuss the properties of these metals on their own. Now, again, most of these are going to be synthetic and unstable. These are where we're going to find a lot of our isotopes, or a lot of our, what's the word I'm looking for? I have no idea. But these are the ones that we're going to find that are nuclear reactive or radioactive. There we go. That's the words I was looking for. Now, because of this, we're going to see that many of them will break down very quickly. They'll actually break down into other atoms, but again, that's something for later. Right now, big thing you need to know is these are the intertransition metals. It's 28. They're composed of what we call our lanthanide and actinide series, and again, they're synthetic and very unstable. Now, this is where we're going to end section 2. We're going to look at, in our next section, how we deal with periodic trends and these patterns that we use to sort of predict how they'll respond and what types of things will happen. With that all being said, have a good evening, and I look forward to seeing you in class. Goodbye.